Question number 66. The compound which will not show geometrical isomerism is. Geometrical isomerism is there due to the restricted movement about the double bond. So in the first compound, you can observe the cis-trans isomerism because this is the compound which is, this is the cis isomer, and you can also make its trans isomer by placing this CH3 at this side. Now, after this, we have the next compound that is 1,2-dimethyl. You can draw this in this way. CH3H. This is the cis isomer. You can also draw its trans isomer by changing the position of methyl group and hydrogen. It means it will also show geometrical isomerism. Now there is third compound that's present here. In this way. In this case, there is not the possibility of cis-trans isomerism, and that's why this is the correct answer also. And if we talk about the fourth option, that is oxime. Oximes also show cis-trans isomerism, and that's why I'll choose option 3 as the correct option here. Answer is option 3. After this, question number 67 I have. Question number 67. In the Carius method of quantitative estimation of halogen, 0.25 gram of organic compound gives 0.5 gram of silver bromide. The percentage of bromine in the compound is. Atomic mass of silver and bromine are also given. We know that Carius method is used for the quantitative estimation of halogen. And here is the halogen, that is bromine. What's the formula for the calculation of the percentage of bromine in the compound? In Carius method, percentage of halogen, the halogen is bromine here, that is equal to mass of AgBr that's formed there. It should be divided by molecular mass of AgBr. Now, it should be multiplied by the atomic mass of bromine, and it's divided by the total mass of organic compound that you are taking. And now, to get the percentage, what you need to do, just multiply 100 to it. Now, let me write here the values. Mass of AgBr that's obtained in this case, if you look at the question, 0.25 gram of organic compound you have and 0.5 gram of silver bromide is formed there. It means you can easily write here the mass of AgBr, that is 0.5 gram. What is the atomic mass of bromine? That's clearly given in the question, 80, and it should be divided by the molecular mass of AgBr. What would be it? It is 108 plus 80. If you sum these two, we will get 188 multiplied by the mass of the organic compound. What is the mass of organic compound that you have taken? 0.25 gram, and just multiply 100 to it. On calculation, you will obtain that this mass is 85.1% approximately. And if it is so, the correct answer that's given here in option 4, that you can easily choose. After this, there's another question. Question number 68. The element which cannot be detected by Lassine test is. If we talk about this test, we generally detect the presence of sulfur, chlorine and phosphorus, but not the presence of boron. And that's why the correct answer is option 3 for this question. And after this, question number 69 I'm just taking. Question number 69, consider the following reaction. We have this particular reaction in which we are adding. Question number 69, consider the following reaction. We have the substrate on which we are just adding alcoholic KOH in the presence of heat. Definitely this will result in the formation of the product that is unsaturated. This is alkene that would be formed here because initially we are taking here the haloalkane. So in this case, there would be the product that is formed. This is the reaction, and you're just adding alcoholic KOH in the presence of heat. In this case, the product obtained would either be this, or another product that you can obtain here is this. Why it happens? Because it has 2 beta hydrogen. That's why 2 different products are formed. So this way, the maximum number of eliminated product formed in this reaction is 2, and that's why option 3 is the correct answer for this question. And after this, question number 70 we have. Question number 70, the correct order of decreasing aromatic character of the given compounds is. We have 3 aromatic compounds given here. Basically, these are the non-benzenoid aromatic compound, heterocyclic compounds these are. If you look at the first one, here is oxygen, then nitrogen is there in the ring, and here is sulfur that's present in the ring. One thing you should always remember, that if we talk about the aromatic character, that depends on the delocalization of electron. And if the lone pair of electron is present on the least electronegative atom, it will participate more in delocalization. So if we arrange oxygen, nitrogen and sulfur in the order of increasing electronegativity, then oxygen is most electronegative, then nitrogen and then sulfur would be there. And on the basis of this, the lone pair present on oxygen would be least involved in delocalization. It means aromatic character would be least in this case. While in case of sulfur, there is the presence of lone pair, and that lone pair is most involved in delocalization. And on this basis, this third compound has maximum aromatic character. Then there would be the second compound, and after that there is the turn for the first compound. This is the order. Where this order is given? This order is given here in option 2, and on the basis of this, you can easily choose this option. After that, question number 71.